Hey everyone, I'm Michael D, and I'm here to show you that you can balance chemical equations. So let's go ahead and get an example up here and get started. A typical chemical equation that you might be asked to balance is N2 plus H2 yields NH3, and your teacher or the worksheet will usually give you some blanks and then say, balance this. Well, what are they asking you? What you need to realize, and I'm going to show you a little technique here that I use with some of my students, is that this N2 is actually an N attached to an N. That's what N2 means. It's two little N blocks stuck together. And H2 means an H stuck to an H. There's two H's and they're stuck together. This is one block. And NH3 is an N stuck to three H's. And I like to think of them as little Lego blocks or building blocks or whatever you want. But in the end, you have to have the same number of little blocks on each side. N's are nitrogens, we have to have the same amount on the left as we do on the right. Because we have two nitrogens on the left, we need two nitrogens on the right. We only have one. So we need two of these blocks. But by putting a 2 in front of this NH3, you're actually building another NH3. It's not just an N that you're adding in here, it's a whole NH3. And you can't just be all slick and cheat and say something like, I'm gonna write N2H3, and that will solve all of my problems, because that's not allowed. That's literally cheating. You cannot change what we're building. You're only allowed to change the amount that we're building. By changing this to N2H3, you're building a totally different little block. We can only build NH3s. By adding a second NH3, we can count the number of H's on the right. 1, 2, 3, 4, 5, 6. There are 6 H's. If you weren't drawing this out, you could multiply and figure out that there are 6 H's, because we're building 2 NH3s. That's 6 H's total to build that, which means we're going to need 6 H's on the left. H's come in pairs, so we can have another one. Now we have 2 pairs of H's. That's still only 4, not enough. We can add in one more. Now we have 6 H's on the left. That's 3 of these blocks. We can put in a 3. We can double check. We have 2 N's on the left, 2 N's on the right. 6 H's on the left, 6 H's on the right. This is now a balanced chemical equation. Depending on who you're working with, some folks will expect that you put a 1 here, or you can just leave that blank. It's kind of like writing a 1x when you're doing algebra. It's not wrong in the beginning, but as you get better, it kind of looks weird. So let's go ahead and do another example. I'm just going to scroll down here and put up another one. This time we are going to do MgCl2, and for those of you practicing naming, that's magnesium chloride, and LiBr, which is lithium bromide, and it's going to produce lithium chloride plus magnesium bromide, and I got that in there, my space, because I still need to have some blanks. Once again, we can draw the little structures if that's going to help. This is a simplified version of these structures. It's just to help us keep in mind what these look like. So we have a magnesium, and this one's attached to 2 Cl's, and we have a lithium attached to a bromine. That looks like this. As I said, these are simplified. As you get farther into chemistry, you'll learn how to draw these in different ways. It's all exciting. You'll get there. Magnesium attached to 2 bromines. We begin with the magnesium. We have 1 magnesium on the left, 1 magnesium. We have 1 magnesium on the right. Okay, looking good so far. We have 2 chlorines on the left, 1 and 2. On the right, we only have one chlorine. We're going to need another one. So let's go ahead and build a second block. We have another LiCl. Now we have two chlorines on the right. But because we just built a second one of these blocks, we now have two lithiums on the right. We only have one lithium on the left. How are we going to fix this? That's that moment where, like, everyone who's watching the video shouts out and says, "We're gonna add a second one!" And I'm like so proud of you, and I clap and I cheer and I get a huge smile on my face because you're totally right. We add a second one. And this becomes LiBr. And we can double check this now. We have two Brs on the left, two bromines, and we have two bromines on the right, which means this balanced chemical equation checks out. We can put our ones in the remaining blanks, or we can just leave them blank. That's not a big issue. Let's do one more example. Scrolling up, and we are going to, this time, we're going to put a good one this time. We're going to put a good one. C3H8. We're going to do a little combustion reaction. Plus O2 produces CO2 plus H2O, and I gotta make sure I leave enough room for my blanks there. Marvelous. Well, this is a beast to write out, this C3H8. And you know what? It really doesn't matter how you draw this right now, just as you're learning these and practicing these, as long as you know that that's just a big block. That's 3 carbons attached to 8 hydrogens. So I'm going to go ahead and I'm going to draw this one, and it actually is not too bad to draw, but it doesn't matter how you draw it, or even if you draw it. If you can keep track of how many carbons and how many hydrogens you have. And we have an oxygen attached to an oxygen, and we have a carbon attached to 2 oxygens, and we have an oxygen attached to 2 hydrogens. And like I said, these are very simplified ways of drawing these. It's just to keep track of it for balancing. We start off with our carbons. We have 3 carbons, that's 3 C's on the left. We only have 1 on the right. How many of these little structures are we going to have to build so that we get 3 carbons on the right? 3! That's right, you got it. We're going to need to build 3 of them. That's the only way we're going to get 3 carbons on the left and on the right. So we're going to build another one, and we're going to build one more. Now we'll check hydrogens. We have 8 hydrogens on the left. Now I know you clever little cupcakes, you may not have had to have drawn this at all, because as you get better at these, you're going to just look at this molecule and be like, there's 8 hydrogens here. And I'm going to be all, yeah, there is 8 hydrogens. You don't need to draw it out. 1, 2, 3, 4, 5, 6, 7, 8. On the right-hand side, we only have 2. Each of these little blocks that we build will give us 2 hydrogens. How many of these H2O blocks will we need to build in order to get up to 8 hydrogens if each one gives us 2? We're gonna need 4. We're gonna need 4 of them, because then we'll have an O. Try and jam all these in here, and another one right below it, and another one right there. And that gives us 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Everything's looking good, but I picked this example on purpose because now we have to deal with oxygens. And oxygens are actually in both of these products. They're in the CO2s and they're in the H2Os. Because we drew these out, you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you did not want to draw these out, you could have done this by multiplying 3 CO2s. 3 times 2 would have given us 6 here. On the H2Os, there's 1 per. 4 times 1 is 4. Add them together, it's still going to give you 10 oxygens. On the left-hand side, we only have 2 oxygens. Oxygens come in pairs. How many pairs of oxygen are we going to need to get up to 10 total oxygens? We have 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs of oxygens will get us up to 10. And hopefully, by drawing out these little structures to help you keep track of how many of each element you have, you too are going to be able to start balancing these chemical equations. I hope that this was helpful. Thank you very much for watching, and I'll be looking forward to seeing you next time.